So it actually ends up, when you all get into Calc 2, being able to reduce the power on problems like A and B will be extremely useful. So let's see how this process starts. And I suppose even before we see how it starts, maybe we should see what the power reducing identities look like, and maybe specifically which one we're going to use. So the identity that we're going to use here is cosine squared of theta is equal to 1/2 times 1 plus cosine of 2 theta. And the reason that this is called a power reducing formula is we go from a power of 2 to a power of 1. The exchange, though, that happens here is, unfortunately, though, we go from theta to 2 theta. Now, let's get started. Okay. If we want to actually be able to use this, we need some cosine squareds here. So how about we rewrite our cosine to the 4th there as cosine squared of x times cosine squared of x. Now let's use this identity here on the right. So we have 10 times 1/2 times 1 plus cosine of not 2 theta but 2x, because our variable was x here. And then times another 1/2 times 1 plus cosine of 2x. And now we can start simplifying. So we have a 10 and a 1/2 and a 1/2 here. Well, all those multiplied together would be 10 over 4, which we'll simplify here in a minute. But now we could also multiply these two together. Okay? If we multiply those two together, we need to FOIL. And so that's going to look like 1 plus 2 cosine of 2x plus cosine squared of 2x. Okay. Now, we weren't just asked to reduce the power here. We want that power to be a power of 1, okay, not a power of 2, 3, 4. And so what that means is this part here is still problematic. Okay, we're actually going to need to use this identity up here again. Is what I want you to note here, though, is in place of theta, we have a 2x, which means that 2 theta would be equal to 4x. Okay. I just like to tell myself that as I go from the left-hand side of this equation to the right, I should double whatever the angle was. So we'll go ahead and we'll simplify this fraction first to 5/2. And then we have, again, 1. I'm going to use some square brackets since we're going to have an extra set of parentheses in here in a minute. We have our 5/2 here, 1 plus 2 cosine of 2x plus, and again, we're going to use that identity, so we're going to have 1/2 times 1 plus cosine of double the angle, which is 4x. And all we have left to do here is distribute this 5/2 through and combine any like terms that we might have. So 5/2, and then 5/2 times 2 is just 5. And then 5/2 times 1/2, it's going to be 5/4. And remember, this is 5/4 times 1 plus cosine of 4x. So how about we just do 5/4 times 1 plus 5/4 times the cosine of 4x. And we only have 2 like terms here, right? This one's cosine 2x while this one's cosine 4x. So those two are not like terms. We won't be able to combine them. But the constant terms we can, 5/2 plus 5/4. And if we add those together, we should get 15/14, or not 15/14, 15/4. Okay, because if we did get a common denominator of 4, this first fraction would be 10/4. So we have 10/4 plus 5/4, which is 15/4. And next, we have the remaining trig terms. So 5 cosine of 2x and plus 5/4 cosine of 4x. All right, and now that probably was a little challenging, but is what I'd like you to do is try and mimic this process we just did, but for part B. Okay. And for part B, this means you're going to need also the power reducing formula for sine squared. Okay. So we have one of the identities that we need up above. The other one we need is just sine squared of theta is equal to 1 minus cosine of 2 theta all over 2. All right, so try and use those two identities here on part B, and when you're done, you can unpause the video and see what happened here. Okay, so if we start off with this 8 sine squared of x cosine squared of x, and we apply our identities, we have 8 times, and so I wrote the cosine squared identity a little bit different. I wrote it as 1 plus cosine of 2 theta all times 1/2. But multiplying by 1/2 is the same thing as dividing by 2. So I do want to point that out. This 1 minus cosine of 2 theta over 2, I could rewrite as 1/2 times 1 minus cosine of 2x. And I'm okay with you writing it either way. It's just whatever one you're more comfortable with. And then we have the identity for cosine squared, which looks like 1/2 times 1 plus cosine of 2x. Okay. And we have that identity right here if we want to look at it. All right, cosine squared theta is equal to 1/2 times 1 plus cosine 2 theta. And now is what we'll do is we'll multiply together the constant terms. So this is 8 times 1/4. Let's write 8 over 4 here. And then we still have these two to multiply. And so again, we'll FOIL. But the nice thing here is when we FOIL, the middle term will cancel out. And so we're just left with 1 minus cosine squared of 2x. All right, let's do a little bit of simplification. This 8 over 4 here we could write as 2. And then in here, we have 1 minus cosine squared of 2x. Okay. We're going to need to use the power reducing formula for cosine squared here. So if we do that, what's this going to look like? Well, it's going to look like 1/2 times 1 plus cosine of double this angle. So double that angle is 4x. And there it is. Okay. We have reduced this down to a power of 1. Let's just do some simplification. Let's distribute the 2 through. We'll get 2 times 1, and then 2 times 1/2 is just 1. So we have minus 1 plus cosine of 4x. And if we distribute the negative through, we should get 2 minus 1, which is 1. And then we have minus cosine of 4x. All right, and that is it. This will be much easier to work with now, depending on what application we're doing. We are back to verifying trig identities. And here you could really start with either side As I always say, I typically prefer to start with the side that looks a little bit more complicated, and this is just because it is easier to simplify something than it is to make it more complicated. So if we do start off with that 2 cotangent, and that should actually say cotangent of theta there. I just realized that was missing. So we have 2 cotangent of theta all over 1 plus cotangent squared of theta. Now, we have a few options here. Okay. One is we could try to rewrite everything in terms of sine and cosine right now. Okay. And that will work out, but it'll get a little bit messy. Okay. And that's not necessarily a bad thing, but if we can avoid it, let's do so. And the way that we're going to avoid this is at some point anyway, we're going to wind up needing to use a Pythagorean identity. And I already see something that reminds me of one of our Pythagorean identities. Let's see what that is. So you might remember 1 plus cotangent squared of theta is equal to cosecant squared of theta. So we're going to go ahead and use that. There we go. So we have 2 cotangent of theta all over cosecant squared of theta. Right? Honestly, this already looks better. Okay. I'm going to go ahead now and convert this to be in terms of sine and cosine. But I do want to point out that's not the only route to take. There are many options here. If you went down another path to verify this identity, that's okay. Next, we could rewrite that cotangent of theta as cosine of theta all over over sine of theta. And then this is all over cosecant squared of theta, which is 1 over sine squared of theta. And now we can flip and multiply. So this is going to look like 2 cosine of theta all over sine of theta times sine squared of theta over 1. And let's look at where we're trying to get to. We're trying to get to sine of 2 theta. So we're probably going to need to use a trig identity that will allow us to go from an angle of theta to an angle of 2 theta. So let's keep that in mind as we continue to simplify here. So now note, we'll have a 2, we'll have a cosine of theta, and we have sine squared theta over sine of theta. Well, if you simplify that, that's just a single sine of theta. And this right here should look familiar. This should look like, actually I'll arrow to it, not the equal sign that I'm about to write. This is something that we could use one of the double angle formulas for. All right, and the double angle formula that we're looking for is the one that is sine of 2 theta is equal to 2 sine of theta cosine theta. In fact, it's the very first one on our list if we were to go all the way back up here. All right, sine of 2 theta equals 2 sine theta cosine theta, and that's exactly what we have. And so then this equals sine of 2 theta. And we are done with that one.